Hey guys, it's Tiffany from SuperEasyMath.com. Today, I'm going to show you how to calculate the mean absolute deviation of a data set. Mean absolute deviation. What is mean absolute deviation? The mean absolute deviation is the mean or the average of the distance of several numbers in a dataset away from the mean of those numbers. It's a special type of average. The formula used to calculate the mean absolute deviation looks like this. Even though this formula looks pretty scary, the calculation is not that difficult. You don't really have to consider the formula if you don't want to. You could just follow the steps that I explained to you. The steps you want to follow when calculating the mean absolute deviation, or the MAD, are: first, you're going to find the mean or the average of the given data set. Then you're going to calculate how much each one of the values deviate from the mean. So how far something deviates means how far it is away from a place. So how far away is a number from the mean. Next, you're going to add the absolute values of the calculated deviations together. Finally, you're going to divide the sum by the number of values to get the mean absolute deviation. Example number 1. Calculate the MAD of the following data set. I have 3, 2, 6, and 1. Well, the first thing I need to do is add my numbers together and calculate a regular average or mean, okay? So that means I'm going to add my 3 plus 2 plus 6 plus 1. Okay? 3 plus 2 plus 6 plus 1 equals 12. When you're calculating the mean, if you remember, the next step you take is to divide your sum by the amount of numbers that you have in your data set. And we have 1, 2, 3, 4 numbers in this data set. So I'm going to divide 12 by 4, and I'm going to get 3. Okay, so that's a regular average or mean. Okay, you should already know how to do that. Now we have another step to take. We need to calculate the deviation or the distance each one of these data points is away from our mean, which is 3. So I'm going to write a new data set down, okay? I'm basically creating a new set of numbers, and I'm going to start with the 3 and just go left to right. So how many numbers away from 3 is 3? 0 numbers away. So of my new data set, my first digit is going to be 0. And I'm going to add it to however many numbers away 2 is from 3. Well, they only have a difference of 1 space, so I'm going to write a 1. And then 6, how many digits away is 6 from 3? It is 3 spaces. And then 1, how many spaces is that away from 3? It is 2 spaces. And when I say spaces, you could think of this as a number line. Okay, so let's say I have a number line and it's marked saying, starting at 0, and then here's 1, 2, 3, 4, 5, 6. Well, I calculated that my mean is 3. So what I need to do is figure out how far each one of these data points are away from 3. So what I'm going to do is I'm going to mark these points on the number line, and then I'm going to count how many spaces away those numbers are from my average. Okay, so my 3, I'm going to mark it right here. That's my 3. Mark it with an X right here. It is 0 spaces away. That's where this 0 came from. My next number was 2. Okay, how many spaces is 2 away from 3? It's 1 space away. See, here's 2, here's 3. It's 1 space away. That's where this 1 came from. Now this 3, well, my next number in the data set was 6. So 6 is over here. How many spaces is 6 away from 3? It's 1, 2, 3 spaces away. That's where this 3 came from. And then 2. That came from 1 because it was 2 spaces away from 3. It was 1, 2 spaces away. And so that's where the 2 came from. Now this is a new set of data that I created. Now what I need to do is add these numbers. And I have 1 plus 3 is 4. And then 4 plus 2 is 6. And now I divide this new number by how many numbers I had. Okay. So it's important to remember you're going to keep this 0. Okay. Don't say, oh, it's 0. It's nothing. You do need to consider it because when it's time to divide, you need to keep 0 as a placeholder because you need to divide by 4 here. If you would have for some reason thought, oh, I'm going to drop the 0, that would have messed you up. You would have divided by 3 and that's going to give you the wrong answer. So anyway, now that you divide by 4, you get 1 and 2/4, and that simplifies to 1 and 1/2, or you could write it as a decimal, 1.5. 1 and 1/2 typically is not going to be how you finalize your answer because it's not in the simplest form. So your answer is going to be either 1 and 1/2 or 1.5. Okay. Let's take a look at example number 2. Calculate the mean absolute deviation of the following data set. So let's say our data set is 8, 2, 10, 5, 7, and 4. I'm going to add all of my data points. 8 plus 2 plus 10, 5, 7, and 4. Okay. When you add all of those numbers up, you get 36. Then you need to divide by how many numbers you have. And if you count how many numbers you have 6 numbers. And so the answer to that is 6. Okay. That's just the regular mean. We don't need to calculate the regular mean. We need to calculate the mean absolute deviation. So we need to take a few more steps. The next steps we need to take are we need to calculate the distance that each of these data points is from 6. So I'm going to draw the number line again, just to give you a visual. And I'm looking and I see that my smallest number is 2. So I'm just going to go ahead and start at, 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. I'm going to mark my mean on this number line, and I'm also going to mark my point. Okay. So I'm going to star the mean. I just calculated that 6 is the mean of that data set. Now I'm going to mark the actual data points themselves. So I have 8 and I'm going to mark it right here. I have 2 and I'm going to mark it right here. I have 10 and I'm going to mark it right here. I have 5 and I'm going to mark it right here. I have 7 and I'm going to mark it right here. And I have 4. I'm going to mark it right here. Now I'm going to create like a new data set based off of how far away these numbers are from the average. 8. How many spaces away from 6 is 8? 8 is 2 spaces away from 6. Okay, so my new data point that is coming from this 8 is 2. And I'm going to add that to my next data point. The number 2. How many spaces away is 2 from the 6? It's 1, 2, 3, 4 spaces away. We're just subtracting, right? And then 10. How many spaces is that away from 6? It is also 4. Now, somebody might say, that's weird. How come they're both the same number? Well, it's because we're dealing with the absolute value. So if you really wanted to get technical, if you were to subtract these numbers, sometimes you would get a negative number, sometimes you would get a positive number. We are taking the absolute value of that problem. So it means you only want to deal with the distance in a positive aspect. So I really didn't bring the negative part here because I feel like it can make it a little more complicated, and you don't have to consider it. If you just keep it positive and think of it from a positive perspective, how far away is a number from the average? Okay. So now 5, how far away is 5 from 6? It's 1 space away. So now a 1 is gonna take that place. 7, how far away is 7 from 6? It's 1 space away. How far away is 4 from 6? It's 2 spaces away. Now I'm gonna add all of these numbers. I have 2 plus 4 plus 4 plus 1 plus 1 plus 2, and I get 14. Now I need to divide by 6 because that's how many numbers I have again, okay? And right there, I get 2 into 6. Or when I simplify that, I get 2 1/3. And then I could even write it as a decimal, and it would be 2.3 repeating, okay? So I would say your answer is either 2 1/3 or 2.3 repeating. I prefer a fraction in this case because 2.3 repeating sort of loses some of its precision because it's a repeating decimal. The fraction is more precise, okay? It's more of an exact answer. So now I want to do something. Before we go on, I'm actually going to write another set of data on the screen, and I want to compare what this spread of the data looks like to another spread of the data, and you'll understand the value that mean absolute deviation has by me comparing these two spreads, okay? So let's say I had a different data set, and my other data set gave me the exact same mean, okay? Remember, the mean of this data set was 6, okay? So let's say my data set is 1, 20, 3, 9, 2, 1. And I want to calculate the mean absolute deviation of this, okay? So I'll start by calculating the mean. So I would add 1 plus 20 plus 3 plus 9 plus 2 plus 1, and I would get 36, okay? Then I'm going to divide that by 6 because there are 6 numbers, and I get 6. Just like I got over here, okay? I'm even going to put a box around this 6 so you can kind of see the parallels, okay? Now, I got the exact same mean, but my data sets look different, okay? This one has like a 1, this one has like a 20, this one has a 2. Like, these numbers over here are a little closer together, okay? You're going to be able to see this a little easier when I write them on a number line. So I'm looking at my numbers to kind of get an idea of how I should draw my number line. And I feel like since I have a 20, I need to make this number line go from 0 all the way to 20 this time, okay? 0 and 20 needs to end here. So I'm going to write my halfway mark, which is 10. And 5 is here and 15 is here. Just kind of like giving myself some guidelines. If I were to start all the way on the left side, sometimes you end up running out of room, or you end up where your beginning numbers were closer together and then you had too much room at the end. So it just kind of helps me make sure I stay a little even. Okay, so this is 1, 2, 3, 4. 5 is already there. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? It's not perfect, but it's pretty good. So I have a number line here. Now, I'm going to take the same steps that I took over here, but I'm going to do it with my new data set. So I have a mean of 6. So I'm going to star 6. Okay? Now I'm going to take all of these other data points and I'm going to mark them just like I did over here on this side. So I have a 1 and I'm going to put an X right here. I have a 20 and I'm going to put an X right here. I have a 3 and I'm going to put an X right there. 9, 2, and 1. I have another 1. So I'm going to put it on top. Let me make sure I have 6. 1, 2, 3, 4, 5, 6. Okay. I want to make sure I didn't miss a number. Now, I'm going to calculate the mean absolute deviation based off of this number line, okay? So I'm going to start by asking myself, how many spaces is 1 away from 6? Well, it's 5 spaces away. And I'm going to go ahead and mark this 5 down here because I have another one. What about 2? How many spaces away is the 2 from 6? Well, it's 4 spaces away. I could count them if I wanted to. 1, 2, 3, 4, or I could subtract in my head. What about 3? How many spaces away from 6 is it? It's 3 spaces away. And what about 9? It's 3 spaces away. And what about 20? It's 14 spaces away. Okay. So now what I need to do is add all of my numbers. And when I add all of my numbers, I'm going to divide that answer by 6 to calculate my mean absolute deviation. So when I add all of these numbers, I get 34, and I divide that by 6, and I get 5.6 repeating, or 5 2/3, okay? Even though we had the same mean for these two data sets, our mean absolute deviations are different. This means these numbers vary a lot from each other. These data sets vary a lot, okay? So let's say somebody were to ask you, hey, does the mean give a good representation of this data? Well, over here, I would say 6 for the mean is a pretty good representation. It's kind of like right in the middle. You got a little bit lower. You have some numbers from your data set that are slightly lower, and you got some numbers from your data set that are slightly higher. Well, let's look at this data set. Even though it has an average or mean of 6, just like the other one, I wouldn't say 6 is necessarily the best representation of the data. You got some numbers that are lower, maybe even you might say a good bit lower. You got a 9 over here, and then you got a number way up here that's 20. Although 6 is the average, it's kind of like by itself almost, okay? It's kind of like the numbers are so spread out that this is, it is genuinely the average or the mean, but it's kind of worth taking note of, okay? Even though it's the average, the numbers that got you this average really vary kind of far away from it, okay? So calculating the mean absolute deviation, or this number, the 2.3 repeating, or the 2 1/3 versus the 5 2/3, it really clearly shows you that this data set is like closer to your mean, okay? The numbers are closer to your mean. Like the mean is a better representation of the data. For this data set, there's a lot more variation. So the numbers are not as close to your mean. See, like this outlier, it like skews the data off, okay? So that's worth knowing, depending on what kind of information you're looking at. Let's take a look at example number 3. Example number 3. Jerome has received the following grades for his final exam. In science, he made a 78, in math, an 85, in English, an 83, and in history, a 72. Find the mean absolute deviation of his exam results. Okay, so we have our data set. 78 plus 85 plus 83 plus 72. When you add all of those together, you get 318. Then you're going to divide by 4 because there are 4 numbers, and you get 79.5. Okay. Now this one is going to be a little more complicated for us because our average, our mean, didn't end up being a nice, easy number. It's not a whole number. It's got a decimal. So it's going to make our math a little more complicated. So I'm not going to draw the number line this time. I could, but I'm just going to subtract. What is the difference of 78 and 79.5? And that would be 1.5. So right now I'm like making that second set of data based off the difference or the distance or the deviation, however you really want to think about it. Okay, and The 85 is 5.5 away from 79.5. And then your 83 is 3.5. And your 72 is 7.5. Okay. So these numbers all tell us how far away they are from 79.5. Now I'm going to add those numbers and get 18. And then I need to divide that by 4 because, again, there are 4 numbers. The numbers you divide by are always going to be the same, okay? Because you didn't change an amount in your data set. And again, like I explained in the first example, if your distant is 0, meaning one of your data sets happens to be the same that you get for your mean, you still include that 0. You should still have the same amount of numbers to divide by. You don't say, oh, it's 0, so I don't have to write it. No. You're going to get your answer wrong. All right. So now I'm going to turn this into a decimal instead of an improper fraction. Okay. So it's 4.5. This is our mean absolute deviation for example number 3. Example number 4. The following data represents the customer care service scores out of 100 of a fast food restaurant in 5 consecutive months. 86, 75, 95, 80, and 77. Calculate the mean absolute deviation. Okay. So those numbers total 413. And then I'm going to divide them by 5 and get 82.6. Okay. That's my mean. 82.6 is my regular old mean that you probably learned how to calculate way before this. Now, I'm going to take this number and calculate my distance or difference or deviation in relationship to each data point. So for 86, that would become 3.4. And then I'm going to add it to 7.6. And then I'm going to add that to 12.4. And add that to 2.6. And then add that to 5.6. And again, all of these are in reference to the data points. 3.4 is how many spaces 86 is away from 82.6. 7.6 is how many spaces away 75 is from 82.6. 95 is for 12.4. 80 is for 2.6. And 77 is 5.6. Okay. When I add all of those numbers up, I get 31.6, and then I divide that by 5 and get 6.32. 6.32 is my mean absolute deviation for example number 4. Now, let's take a recap. First, you're going to find the mean or the average of the given data set when you're calculating the MAD. Then you're going to calculate how much each one of those values deviate from the mean. Next, add the absolute values of the calculated deviations together. And finally, you're going to divide the sum by the number of values to get the mean absolute deviation. Now you try. Comment with the correct answer below. What is the mean absolute deviant or the mean absolute deviation of the following data set? 10, 1, 5, 7, 2. Once you've commented, head over to my website, supereasymath.com, and click on video answers to see if your answer is correct.
Did you find this video helpful? Well, you can get more help from me on my website, supereasymath.com. While you're there, you can pick up my top 5 math tips to make learning math easy.